Hi everyone, Angie Jones here. I'm the Senior Director of Developer Relations at Applitools and Test Automation University. Today, I would like for us to go for a ride as we explore the new upcoming features of Selenium 4. Let me start off by just saying I'm not an expert in Selenium 4. In fact, it hasn't been officially released yet. And to answer your burning question, no, we don't know when it'll be released, as a date has not yet been specified. That's why the name of this talk is Test Driving Selenium 4. So everything today will be based on exploring the alpha and beta versions and using my insight and experience as an automation architect to guide you. Okay, so buckle up and let's ride. The first feature I'd like to cover is relative locators. So we're all used to, the standard approaches to locating elements. So ID, name, class name, XPath, CSS selector, et cetera, right? Selenium 4 is offering a new approach to this where it allows you to identify elements in relation to other elements, such as finding an element to the left of another element. Likewise, you can also find elements to the right, above, below, or near. Let's look at an example. Here's a grid of great books on test automation. Let's have a look at this classic book, Agile Testing. If we wanted to verify that the book to the left of this is Experiences of Test Automation, relative locators will allow us to do this. Let's see how. So here's the DOM for that list of books. And as you can see, Agile Testing is an LI and it has an ID of PID3. And what we want to get a hold of is the element to the left of this, which is also an LI, and it has an ID of PID2, okay? So within our code, we do driver.find element just like we currently do. However, instead of using one of the existing locator strategies such as by ID, we instead use this new with tag name method. Now, within this method, we give it the tag name of the relative element that we're looking for. So we know the element to the left is an LI, so that's what we provide here. And then we specify the direction to look into, right? Since we want the LI that's to the left of PID3, we use this new to left of method. And inside of there, we provided the locator of the main element. So that PID3, again, was the Agile Testing book. That's the main one. Now, given this, we can then assert that the ID of the returned element is PID2. But not so fast. Our test actually fails because the element found to the left of PID3 was PID1. What? Why is this? Well, let's take a look at the application again. So just to reiterate, we asked for the element to the left of PID3 and we were given PID1. It's not the element that's immediately to the left of PID3, but it is indeed to the left, right? And when we think about how Selenium works, it makes more sense. Anytime we ask Selenium to find an element, whether that be with relative locators or with traditional locators, by default, it starts at the root of the DOM and it's going to return the first element that matches that locator. So in our case, we said, find us an LI element that is to the left of PID3. And that's exactly what Selenium did. So what if we ask Selenium to find us a list of all of the elements to the left of PID3. We should get both PID1 and PID2, right? Well, yeah, we do, but we also get PID5 and PID6 as well. Where did those come from? Let's look at the app again. Okay, so PID3, that's the main element, right? And we ask Selenium for all of the Li elements that are to the left of PID3. And yes, when we look at this, technically PID2, PID1, 2, 5, and 6 are all to the left of PID3. So this is working as designed. It's just not really as intuitive as one might expect, right? So what do we do to say, look, Selenium, I want to make sure that PID2 is where it's supposed to be in relation to PID3? Well, we can change some more relative locators. So if I say, find me the Li that's to the left of PID3, but also to the right of PID1, that should get me PID2. So let's try it again. We say, find us an Li element that is to the left of PID3 and is also to the right of PID1. And then we expect that this will be PID2. And yes, that works. This test would then pass. Okay. Now, if you're going to use relative locators, you'll need to be careful. In my limited exploration of this feature, I ran into a couple of gotchas that you should be aware of. One of which is that our tests don't always run in the same window size. So when testing a UI, it's a really good practice to make sure that the scenarios work in, various responsive viewports that your application supports. Well, you can probably see right away that our test that uses relative locators is broken when we try to execute it against, say, iPhone 10 viewport size, because none of the books are to the left or the right of each other. This whole grid changes into a list view. So this is definitely something to keep in mind. In fact, if you're going to use relative locators, I really strongly suggest, even if you don't use relative locators, but especially if you use relative locators, I strongly suggest that, you really think ahead about future proofing that and the maintainability of it, okay? Another thing to note is that the DOM can be a mysterious place, right? And everything isn't always as it seems. For example, although working with the list of books was a bit complicated at first, once we realized how it worked, it was pretty straightforward, right? But every case won't be like that. Let's look at this application, for example. It's a to-do list with 2 items, and each item has a radio button and a label. So let's say that I wanted to click the radio button that's next to the Goodbye World label. Seems like a really great use case for relative locators, right? So let's try that out. Here's the HTML for that Goodbye World label and the radio button input that's next to it. And then here's the code that says, find the element with a tag of input that is to the left of a label with the text, Goodbye World. Okay. All right. So this seems good, pretty straightforward, much easier than the books. Yeah. However, when we run this, it gives a no such element exception. Gasp, right? This is a bit puzzling because the input is clearly to the left of the label, but yet Selenium can't find it. So what could possibly be the problem here? Well, apparently looks can be deceiving, and this has become a proper mystery. I dug deeper into how relative locators was implemented, and I found a clue. So under the covers, Selenium is using a JavaScript method called getBoundingClientRect, which returns the size of an element and its X and Y coordinates within the viewport. I ran this getBoundingClientRect method on both the label and also the input, and aha, I figured it out. As you can see, both of these have an X position of what? 838, right? So even though on the surface they appear to be side by side, the label is actually overlapping the input. So mystery solved here. This is why the input element cannot be found to the left of the goodbye world label, because it's not actually to the left. The elements, they must be greater than 0 pixels apart to be considered relatives. And that's the same for left, right, above, below, and near. So as shown here, sometimes elements appear to have different X and Y coordinates. However, they can be overlapped in the DOM. In cases like these, where the X and or the Y coordinates are two elements and they're the same, the elements are not considered to be relative to each other. Now, it's great to have another tool in our tool belt, but my advice is to use relative locators sparingly. I think using IDs or names as locators is still by far the best option. And everything else, including relative locators, should only be used when ID and name are not available or cannot meet your needs. Okay. In addition to the gotchas I've demonstrated with responsive testing, with overlapping elements, with unexpected neighboring elements, there's also this huge dependency on the layout of the page. As additional elements are added, as they're removed, as they're rearranged, all of this stuff is inevitable, and there's a likely chance that your tests are going to break. So I view relative locators as a fragile strategy. That doesn't mean that there's no use for them, though, right? In fact, there's other tools like Sahi and Tycho who already have a similar feature. So there must be a demand for this. But just please, as always, use good judgment and only use relative locators when you absolutely need them. Okay. I also recommend that you use relative locators for interaction and not for verification. For example, clicking the button next to the label, this seems like a good use, right? However, attempting to verify the appearance of the application via the DOM, this is not a reliable strategy. Okay, so another feature in Selenium 4 is a convenience method to open new windows and tabs. So opening a brand new window in Selenium 3, it wasn't very intuitive. Like there was no built-in method to do this, and we would kind of have to, send command or control keys to the body element of the DOM and like jump through these hoops. In Selenium 4, this becomes much easier to do. So we call get off of our driver object to open the initial window, just like before. And then when you're ready to open a new window or a new tab, you can call driver.switch2. And from there, there's a new method here now called new window. And inside of new window, you can specify whether you want to open a new window or if you want to open a new tab. And you can do this by using this window type enum as shown here on line 2. So that window type has a tab enum and also a window enum. And depending on which one you pass in, this will open a blank window or a blank tab, okay? From this blank window or tab, to enter a URL, you're going to call either driver.get again and pass in the new URL, or you can call driver.navigate.to and pass in the URL. Either one of those is fine. Then to switch back and forth between those windows and tabs, you would use the same approach that we used in Selenium 3, which is by calling driver.getWindow handles. And this returns the handles for both windows and tabs. And then you call the driver.switchTo.window to get to the one that you want, okay? So this feature is very straightforward. It's essentially just a convenience method that allows you to open new tabs or windows without having to do a lot of work to do so, okay? All right, so this next feature is very exciting. It's Chrome Devtools Protocol, or CDP for short. And this is essentially a set of tools that enables you to access and control Chromium-based browsers via Chrome DevTools, all right? Now, you know what Chrome DevTools is. That's the place where you go and you inspect elements to find their locators. But there's lots of other domains here as well, such as network and performance and security and so much more. And there's also a bunch of commands and sensors available in Chrome DevTools as well. Now, Selenium 4 is providing an API that is essentially a wrapper around the raw CDP commands. And this will make it easier for us to use right there in our test code. Now, access to CDP from our tests, I can't overstate how amazing this is. This opens up a world of possibilities for us as testers. For example, we can mock the geolocation of our browser to do testing in areas where we aren't actually physically located. For example, let's say that we wanted to test the find the store functionality of a business. This sort of feature uses your browser's geolocation to determine where you are so that it can provide, contextual information that's relevant to you. But how do we make our browser think that we're somewhere else? We can change the geolocation, okay? Chromium Driver, this is a new driver, and I'm giving you a little bit of the architecture before I get into it, but Chromium Driver is the new driver that can be used to interact with Chromium-based browsers such as Google Chrome and Microsoft Edge. The browser's specific drivers like Chrome Driver and Edge Driver, they still exist in Selenium 4, but now they inherit from Chromium Driver instead of from Remote WebDriver, which is what Chromium Driver now extends, okay? From Chromium Driver or any of its children classes, such as Chrome Driver as you see on line 1, you can now access this get Devtools method, which returns a Devtools object. The Devtools object has methods to manage CDP sessions, to do things like add and remove listeners, and most notably to send CDP commands. So we can use this for our scenario where we want to mock the geolocation. But how can we do this? Well, to get the available commands and their options, you can consult the Chrome Devtools Protocol website. And I put the link right here for you, okay? When you go there, just kind of search for what it is you're trying to do. So I knew I wanted something about geolocation, so I searched this for geolocation. And when I did, I saw that there was some methods. So notably was a set geolocation override method. And it showed me the command for that. And also it showed me which domain this belonged to, which is emulation. Also, it provided the arguments that this takes. So it takes a latitude, a longitude, and also the accuracy. Okay. So, how do we add this to our code? Well, first, you need to create a new session, and that's using the Devtools object from your driver, right? And then we can use the send command. Now, this command is where this is the one you use, or this method is the one that you use for any of the commands that you want to execute. Okay. So here we are passing the CDP command that we want invoked. And this mirrors exactly what we saw on the website, right? So emulation.set geolocation override. And notice this isn't in quotes or anything. This is actually now in Selenium. This emulation is a wrapper class around the emulation domain in CDP. And there's one for all of them. There's like 40 different domains, and Selenium 4 provides a class for each one of those domains. And each domain's class has methods that resemble the methods in the CDP. So that's wonderful, right? So after we specify the command, finally we pass in the parameters. So the latitude, the longitude, and the accuracy parameters that we saw on that CDP website. And that's it to send the command. Once we've done that, we can go ahead and launch a site. The browser is going to perceive us as being in the geolocation that we've mocked. Isn't that nice? So this is pretty cool, okay? With Selenium 4, we can literally do anything that's possible from Chrome DevTools, and a lot is possible from there. For example, let's say that we wanted to listen for network events. We could do that. We could even emulate like different network conditions, such as like being offline. So imagine that test now. You're testing your application in offline mode without necessarily having to intervene manually to like unplug something. You can add this to your test scripts now. Or you can do something like setting the connection type to 2G. So you can test how your application behaves with slower networks. And this is really important. I remember when I used to work at Twitter and how we would get a lot of complaints from other, countries outside of the US saying like it doesn't work as well when the network is slower. So this is a great way to be able to just kind of add this to your script, run all of your tests, and see how your application performs, right? And this is just the tip of the iceberg, right? CDP has lots of various commands that allow you to control and monitor the state of your browser. And with Selenium 4, we'll be able to easily leverage this. So really, really powerful stuff here. Now, there's so much more you can play with in Selenium 4. So you might want to try it out on your own applications. In fact, I really encourage you to do so. The Selenium project is open source, and one important way to contribute back to this lovely project that's given us so much is to find and report bugs. And that's what I've been doing. So I've actually opened a couple of bugs on, the alpha and the beta releases of Selenium 4. And that's been helpful. Think how nice that is for them to know that up front before it's used widely by the community. So they can kind of get some of the kinks out, okay? If you're using Java, you can go to Maven repository and search for Selenium Java, and I've included the link there. And you'll see the version 4 releases here. Notice they're in beta mode, and you see all of the various alpha ones as well. But what this essentially means is that You shouldn't use this in your actual work projects, right? Because it's not official yet. Things are not final. They could change, be added and removed. You don't want to get in a state where you're depending on, this beta version. But I do encourage you to maybe make a little side project for your application. Try some things out just so you can get the hang of it and make sure that, the newer features are meeting your business needs. Okay. You can also add the dependency to your project. So on the Maven repository, it has the various dependency engines, and you can just copy that code and place it into your project. All right. Or better yet, Shama Ugale has written a step-by-step guide for Java and JavaScript users on how to install Selenium. So definitely check that out as well. Okay. All right, good folks. So we have come to the end of our road trip here. Hopefully this gives you some insight into some of the new features of Selenium 4 and how they might be useful. I hope that your brains are churning and thinking of ideas on how you might be able to incorporate some of these newer features in your project. I cannot wait to see what you all do with it.